double sideband suppressed carrier, double sideband suppressed carrier, and it is applicable for mu greater than 1. Mu means modulation index. Mu means modulation index greater than 1. Okay. So generally the thing is we have single tone modulation, multitone modulation. I will take up multitone modulation first. And modulated signal S of t, modulated signal S of t is direct multiplication of C of t and M of t. Direct multiplication of C of t, M of t. And we know that C of t is AC. C of t is AC cos 2 pi fct. AC cos 2 pi fct. This is S of t. If we calculate the Fourier transform, S of f will be AC by 2 m of f minus fc plus m of f plus fc. And the thing is, if we have DSBSC modulator, we will apply carrier and then message signal, message and carrier. Output is S of t. If the message signal spectrum is a triangle M of f. Spectrum means frequency domain after applying Fourier transform. Spectrum means frequency domain after applying Fourier transform. If we assume, let the spectrum be for message signal be a simple triangle for S of t. This is the output and this is the input. So output, the spectrum will be triangle shifted left and right. Triangle shifted left and right. And this is plus Fc minus Fc. Carrier components will not be present. Carrier components will not be present. This is spectrum of output. This is spectrum of output. Okay, output spectrum. Output spectrum. And here we don't have carrier components, the pillars at plus Fc minus Fc. Pillars at plus Fc minus Fc. That is called suppressed carrier. Carrier is suppressed. And we will gain some power. Okay, power loss can be reduced. Power loss can be reduced by suppressing the carrier. We will gain some power. Okay, this is about the diagram. And this is the multi-tone modulation. Let this be 1A time domain, 1B frequency domain. In multi-tone modulation, you can remember the diagrams alone. In this complete discussion, in this complete slide, you can remember only the diagrams. Carrier are suppressed. Okay, only the triangle at the input side, 2 triangles at the output side, but output side that carrier pillar components are suppressed. Okay, so this is the point I want you to remember from this discussion. Now I will go to single tone modulation. Single tone modulation. Now I have S of t is nothing but M of t into C of t. I will multiply AM cos 2 pi FMT is the message, and then AC cos 2 pi FCT is the carrier, and I can write AM AC by 2, then cos 2 pi Fc plus Fm into T. Fc is high frequency, so I am writing Fc first. Next, cos 2 pi Fc minus Fm into T. Okay. So this is the time domain. I will give it as 2A. If I draw the frequency domain, okay, I will just write the equation for frequency domain. So AM AC by 4. Okay. One cosine can be written as del of F minus Fc plus Fm, then del of F plus Fc plus Fm. One cosine I completed. Okay, I am writing it at 2 terms. So one more divided by 2 I have taken at the outside of bracket. Okay, AM AC by 2 is there. I have written divided by 4 because one cosine I am writing as 2 delta and divided by 2 I am already putting outside the bracket. Now the second cosine I am writing, second cosine, del of f minus fc minus fm, and then del of f plus fc minus fm, f plus fc minus fm. Okay, so you can see these two are for first cosine, first cosine, then these two are for the second cosine, second cosine. Okay, now if I draw diagram for this, let this be equation 2b. If I draw diagram for 2b, what will happen? This be equation 2b, the spectrum of output, spectrum of output, S of f. If I draw, so fc is there, fc plus fm, and then fc minus fm. Okay, at fc it is suppressed, carrier is suppressed, so carrier component will not come, only the sideband components will be there, and the height is am ac by 4 and am ac by 4. Okay, and on the other side, on the negative side also, this is minus fc plus fm, it will come to the right side, minus fc minus fm, it will come to the left side. We will have only sideband pillars, we will have only sideband pillars, and the height is ac am by 4 and then ac am by 4. Okay, so this is about the spectral components. Now I will tell you which is the lower sideband, which is the upper sideband, which is the lower sideband, which is the upper sideband. Origin. Okay, now this is upper sideband component, lower sideband component, upper sideband component, lower sideband component. Okay, you see the frequencies, you see the frequencies, positive fc, positive fc. Okay, fc plus fm, fc plus fm, fc minus fm we have. So minus means it is shifted to the right. Okay, this minus means it is shifted to the right. Okay, right side. fc plus fm, fc plus fm, this is the USB component, USB component. Minus means this is shifted to the right side, minus means this is shifted to the right side. fc minus fm means this is the LSB component on the right side. Okay, so minus means right side and LSB component, minus means right side, this is USB component. Okay, I have shown you right side, one LSB, one USB, what are the things. Okay, so now I will go with the other two. Plus means it is left side. Okay, plus means it is shifted, pillar is shifted to the left side. This plus means pillar is shifted to the left side. Left side we have one USB, one LSB. Okay, plus F plus. Plus means the pillar is shifted to the left side with respect to origin. With respect to origin. FC plus FM. FC plus FM. This is the frequency you can see, FC plus FM. And this is the USB component. And F plus. Plus means it is shifted to the left side, and then fc minus fm means this is a LSB component. Okay, so one USB, one LSB I have shown you. This is the white color. Okay, one USB, one LSB I have shown. Okay, so this is about the spectrum in DSBSC, frequency domain single tone modulation spectrum. If it is multi-tone, we will have triangles representation, output spectrum. If it is single tone, this is the spectrum of output. Okay, this is the spectrum of output, spectrum of output in single tone modulation. Now I will go with calculations, power calculations. Okay, I will go with power calculations. We have only sideband power, no carrier power. So total power is nothing but only sideband power. And the sideband power is, we have LSB sideband, okay, lower sideband, upper sideband, okay, lower sideband, upper sideband. Now how to calculate power? How to calculate power? And totally if you add both the LSBs, the height will become AMAC by 2. Okay, 2 times LSB is there, both heights you have to add. Okay, total LSB. And total USB if you add, similarly Total USB, again it is AM AC by 2. Now power means RMS value. So whatever we have written by the side divided by root 2 whole square. Okay, this is the voltage or height. Strength, voltage or height. Okay, strength, voltage or height is represented on y-axis. All these pillars heights are voltage, strength or height. Okay. Now this is voltage means RMS value divided by square root 2 whole square divided by R. R I will take as 1. R I will take it as 1. AMAC divided by 2 root 2 whole square, okay, divided by R. This is about LSB. And RSB AMAC divided by 2 root 2 whole square divided by R. If I take R value 1, if I take R value 1, AM square AC square divided by, okay, 4 into 2 is 8 plus AM square AC square divided by 8. So finally, the total power is AM square AC square divided by 4. In the case of DSBSC, in the case of DSBSC, the total power is nothing but AM square AC square divided by 4. This is the total power. Carrier is suppressed. Carrier is suppressed. Okay. So now I will go with the bandwidth calculation. Bandwidth calculation. Positive side only we will take for bandwidth calculation. This is higher cutoff frequency. This is lower cutoff frequency. This is the bandwidth. This is the bandwidth. Okay. And the bandwidth calculation is nothing but higher cutoff minus lower cutoff. If you substitute FC plus FM and then minus FC minus FM, and we will, this 2 FC and minus FC will get cancelled. 2 FM is the bandwidth. In DSBSC also bandwidth is 2 FM. Okay, in DSBSC also bandwidth is 2 FM. In AM as well as DSBSC bandwidth is 2 FM. Okay, these are the derivations we have done. These are the derivations. Bandwidth 2 FM and total power is AC square AM square divided by 4. AC square AM square divided by 4. Okay.